Hello, welcome to the practice quiz covering section 6.1 through 6.4. This is a practice quiz, so I'll put practice right there so we can make sure that we know this isn't the real quiz. It's just for practice. All right, so the first four problems, everything works out perfectly. You can take the square root, the cube root, or the fourth root of anything in this situation. So your yellow paper is handy to look off of, your colored paper, whatever color it is, for the square roots, cube roots, fourth roots, all that stuff. So 121, we worked with these numbers quite a bit, so hopefully we recognize that 11 times 11 is 121, so it's 11. And then basically with square root, you're just cutting the exponents in half. You're taking the exponent and dividing it by the index. So it's 6 divided by 2. So it's x cubed and y to the first. And you don't have to write a 1 there. Since this is the even, even, odd situation, we add absolute value to both of those. Number 2, cube root of 64 is 4. And then the 3 divides into 6 2 times. So it is x squared, and then 3 divides into 12 4 times, so it's y to the fourth. No even, even, odd, so we leave it as um, no absolute value necessary. The next one's cube root, so we kind of went square root, cube root. This is cube root again, but it has division in it. Don't be freaked out by that. Just take the cube root of everything. And there's 4 items, 1, 2, 3, 4, that you're taking the cube root of. So we got 1, 2, 3, 4 things. Take the cube root of all of them. So on the cube list, we see 125, so it'd be 5 x squared. And then we got 2. Cube root of 8 is 2, and then just y. And the last the last one here is 256. So we look at the fourth column, and we look down there, and the fourth root of 256 is 4. So we get 4. The uh, index gets divided or divides into the exponent, so it's x to the third and y to the fourth. Now this is even, even, and this right there is odd, so we go ahead and we add absolute value, only necessary around this. We're done worrying about the absolute value, because pretty much from here on, the directions in the book will say things like assume that all variables are positive, so we don't really need to worry about the absolute value so much anymore. So number 5, this is where things don't work out so well. You can't take the square root of this. So we split it up into what we can take the square root of, what we can't take the square root of. 54. The square root of 54, no, not so much, but we go down the list and we look for a number that divides into 54 that is a perfect square. And pretty quickly we find 9. 9 times 6 is 54. The index is 2. 2 does not divide into 5, so I drop it down a power. So I make it 4, and there's a leftover x. 2 does divide into 10, so it's y to the 10th is a perfect square. So the perfect squares are in the front, and the square root of 6x is the junk in the back. Junk. Can't take the square root of that. So my final answer is 3x squared y to the 5th, and then times the square root of 6x. This is the same problem. We sort it into what we can take the cube root of and not take the cube root of. And that's where it's different, is because we're taking out perfect cubes instead of perfect squares. So you look at the cube list and you run down through it and you say, oh yeah, 64. 64 divides in there 4 times. So we split up to 64 and 4. 3, does 3 divide into 5? No, because remember doing the exponent divided by the index. So does the 3 divide into that 5? No. So we drop it down 2 powers. We get x cubed and x squared. And does 3 divide into the 2? No. And if I drop it, it's not going to do anything, so I just make it y squared. And then I only have to drop this down once, so make it z cubed and then z over here. Now I've run out of space, so whoops. Bring that back. Undo, undo, click here. I gotta lock this into place. So we go here and lock into place. Lock into place. Now I can grab this. Okay. So I'm going to slide. Whoops. Come on, smartboard. There we go. And now I need a z in there. So if I multiply this back together, um, it it works out because the 4 times the 64, the x squared times the x cubed, the y squared, and then the z times the z to the third makes the original thing up there. So I take the cube root of this guy here. This is the good stuff. I get 4xz, and then cube root of x. Oops, I lost the 4. The cube root of 4x squared y squared z. And that's the answer. Now, for the next two problems, we're going to do the exact same thing, except for we're going to multiply things together first, or divide things together first, and then sort from there. So I'm going to multiply these together. 1 square root. 3 times 8 is 24. X to the third, because when you multiply like bases, you add the exponents, and y to the eighth. Now I'm going to sort it out. What can I do there? Okay, 4 is a perfect square, and 6. And in class today, people are like, well, always put a bigger number in the front and a smaller number in the back, and that has nothing to do with it. It has to do with the 4 here is the perfect square. Now we're going to take the 3, or the 2, divide into 3 now, so we drop it down a power, and x, and then 2 does go into 8, so y to the 8th all goes to the front. So now we can take the square root of the front stuff, which is 2x y to the fourth, and then square root of 6x. So the next problem is the exact same thing. We're multiplying it together first. So we get cube root. 7 times 8 is 56. X to the third, y to the seventh, and z squared. Now we split it up into what I can take the square root of, what I can't take the square root of. So 56 is 8, and then x cubed. Oh, 8 times 7. 8 times 7 is 56. X cubed all goes to the front. 3 divides into 7. No. So I drop it down a power, make it y to the sixth, and y is left over. And then z squared, there's nothing to divide the 3 into, so the whole thing is junk. I'll throw it at the end. Now I can finish this off. I get 2xy squared, cube root of 7yz squared. All right. Now we're going to divide and sort. So I'm going to divide first, fourth root. 188 divided by 3, or 288 divided by 3 is 96. And then these are ones right there. When you divide like bases, you subtract the exponents. So it's x to the 9 and y to the 5. Now we have to look at the fourth column because I'm doing the fourth root. I split it up into the fourth root of something and the fourth root of something. Now 16 is in the fourth root column because I can 2 times 2 times 2 times 2 is 16. And so 16 divides into there 6 times. Does 4 divide into 9? No, so I drop it down a power and make it x to the 8th and x to the first. And then I got to drop down 1 power, so I make it 4 and 1. And then when you get done with this, again, I've always said this in class, you need to make sure that it makes the original. 6 times 16 is 96. X times x to the 8th is x to the 9th, and so on, y to the 5th. Okay, we got the good stuff here. 2x squared y, fourth root of 6xy. Perfect. Okay, next we divide again, and now we're going to take the square roots. Divide, and we get 98. Subtract the exponents when we divide, we get 3, and y to the 6th. Square root of all that. So it's a square root, and we get 49 and 2, and x squared, and x, and y to the 6th, the whole thing comes because the 2, the invisible 2 here, does divide into the 6. To finish it off, I do 7x y to the third, square root of 2x. Let's see, how are we doing on time? 9 minutes, perfect. All right. Now we're switching sections. These come out of section, those are all out of section 6.2. This is out of section 6.3. We have to have like terms in order to be able to add things together. So we do 3 radical radical plus 4 radical radical. I'm going to simplify my radical, simplest radical form. So 72, it doesn't take too long going down the square list to see that it's 36 times 2. 36 is a perfect square, 6 times 6. And then 25 and 2. So um, this is all multiplication. That's 6 times the 3 is 18, radical 2. And then it's 5 times the 4, because that's the square root of 25 is 5. So that'd be 20, radical 2. And these are now like terms. They both share the square root of 2, so they are the same size pieces. I have 18 of them, and 20 of them make 38 radical 2. Yay! The next problem is the same, except for its cube root. So I go cube root, minus 2, cube root, and cube root. 8 and 2. 8 is a 8's a cube root, perfect cube. And I can take the cube root of 8, and then it doesn't take too long to figure out that it's 27 and 2. I bet you we've split 54 up into 27 and 2 like 10 times now in class, because it just kind of, it's an easy one that keeps popping up. So we have 2 cube root of 2 minus, that's 3 times 2 is 6 cube root of 2. So the same size pieces, I have 2 of them, minus 6, I'm down in the hole, negative 4 cube root of 2. So I have a negative number because 6 is larger than 2, and I'm subtracting 6 from 2, so I had to use some negative numbers to do that. Okay, next page. Now we are foiling to find the answer. We're multiplying two radical expressions together, or two radical binomials together. FOIL is the name of the game here. 3 times 3 is 9. And minus 3 radical 2 plus 3 radical 2 and minus radical 4. Those two cancel each other out, so it's 9 minus the square root of 4 is 2, and I get 7. The next one, I FOIL again, I get 20 minus 10 radical 2. On the inside, I get positive 8 radical 2, and then minus 4 radical 4. So this would be 2 times 4 is 8, so that'd be minus 8. So the 8 subtracted from 20 is 12, and then these go together as like terms. 10, you owe your uncle 10 bucks, you pay him back 8, so it's minus 2 radical 2. So when I FOIL that out, I get another binomial radical expression. All right, now we're going to go through the ones that don't take very long at all. When you have the same exponents, you can multiply the bases. So it's 81 to the 1/2, and that means square root. The square root of 81 is 9, so the answer is 9. When you have the same base and you multiply, you add the exponents. So I've just added the exponents. 1/4 plus 1/4 plus 1/4 is 3/4. So it's 5 to the 3/4 power. The next one, we are rearranging it to radical form. So I'm going to do radical, and then I got the little song. Mr. Jackie knows the exponents. All the children know the exponents. E-I-E-I-O. The top is the E, and the bottom is the I. So the index is 5, and the exponent is 3. Now we're just going backwards here. So this would be 2/3. Now we are going to apply that. So this is the index, and this is the exponent. So I have to do the 5th root on 243. So I look in the 5th column. I look in the 5th column, and that would be 243 is there, and it's 3 to the 5th power. So if I want the 5th root, I just want the 3. So the answer is 3 squared, which is 9. So you do, I always do the index first and the exponent second, because I really don't want to square 243 and then take the 5th root of it. Same thing here. I'm going to take the cube root of 125 negative, so it's negative 5. and then I raise it to the fourth power. So negative 5 times 5 4 times multiplied together would be a positive number, 625. Okay, the last page. Again, these last ones here don't take too much time. This one here, you're following the rule. When you multiply like bases, you add the exponents. So essentially, I'm adding 1/4 plus 3/2. I'm just adding the exponents. I'm going to do this the old-fashioned way. I'm getting a common denominator, so I'll multiply each one of those by 2. So now it's 1/4 plus 6 fourths. So 1 and 6 make 7/4. So the answer is x to the 7/4 power. X to the 7/4 power. Number 22, I, there's nothing fancy about this. Just multiply 2 times 3, and when you multiply like bases, you add the exponents. So it's 6x to the 6th power. Now I'm taking the square root of all this. How do I know that I'm taking the square root? Because the 1/2 power means square root. Square root of 9 is 3. We have a power raised to a power. We multiply the exponents. So that would just be x, and then y to the negative 2, because I multiplied negative 4 times 1/2. And then I cross the line, and I change the sign. Yeah. And the last problem is division. When you divide like bases, you always subtract the exponent. So essentially, this is 3/5 minus 2/3. I'm going to do, again, this the old-fashioned way. I'm going to multiply the bottom by 5 and the top by 5. That gives me, no, that would be bad. That would be bad. I got ahead of myself. Multiply the bottom by 3 and the top by 3. That would make 15. I'm going to multiply the bottom by 5 and the top by 5. That makes 15. So now I have the common denominator. So that would be 9/15 minus 10/15, which is negative 1/15. So this becomes x to the negative 1/15. Cross the line, change the sign. So it becomes 1 over x to the 1/15. And there we go. There's all the answers. We're good to go. Good luck on the quiz.